Hello everyone, we are at Beyond the Formula. Let's study a family of curves that is conic sections. Now what is conic section? The word conic section literally means what? A section obtained from a cone. If we cut a cone by a plane and observe the intersection, the different curves are produced. These curves are called conic sections. Now we have studied what? We have studied circles, ellipses, or we have heard about, or we can say we have heard about ellipses, parabolas, hyperbolas, right? Now they appear completely different curves, but surprisingly what, all of them can be generated from a single geometric object, which is a cone. Now what is cone? What is cone? Imagine a straight line. Imagine a straight line rotating about a axis around a fixed axis while making a constant angle with it. Now the surface generated by this motion, the surface generated by this motion is called a cone. Now this this is the point we say vertex, and this is the axis. Now and this is the generator, making a fixed angle, say alpha. Now when it moves, when this straight line rotates around this axis, it creates or it develops a shape that is called cone. Okay, vertex, axis and generator are the important parts. Now we know conic sections, we know cone. Now let's see how these are made, or these are developed from a cone. Consider a cone. We have to take two right circular cones like this, and a plane, and a plane. This is a plane. And this is two cones. Now the angle, let's see. This is the axis. The cone is making semi-vertical angle alpha. The cone is making semi-vertical angle with the axis alpha. So we have alpha is equal to semi-vertical angle of cone, right? Now we have another angle beta. We have another angle beta, that is the angle made by plane with axis of cone, with axis of cone. Now see, look at this. If I take up this plane, if I take this plane and cut the upper half of this cone, like this. If I take the plane and cut the upper half like this, making beta equals 90 degree with the axis, making beta equals 90 degree. Now imagine what type of shape this plane will create from top side. Do you see a circle, right? you will see a circle from top side, correct? Now this beta plays an important role. This beta plays an important role in what? In explaining or in determining what type of conic section will be produced if the value of beta is changed with respect to alpha and the axis. So let's see here, or draw another diagram. We have if I keep beta less than 90 degrees but greater than alpha, beta less than 90 degrees but greater than alpha. So we have alpha here. Now look at the plane here. Now beta is less than 90 degrees, right? So the plane will look like what? The plane will look like this. Let me draw it. The plane will look like this, and the shape here will look like this, right? The shape here will look like this. Now what is this? This is an ellipse. This is an ellipse, right? Now varying beta, we will get all different kinds of conic sections. I have drawn it here already for the clarification. Look at this. Here for circle, beta equals what? 90 degrees. For an ellipse, beta is greater than alpha but less than 90 degrees. For parabola, beta equals alpha. You see, in case of parabola, this plane here will appear parallel to what? Will appear parallel to these lines. Will appear parallel to these lines, and it will only cut either the upper half or the lower half cone. It will never cut both the cones. Now for the hyperbola, we have beta less than alpha. If you have beta less than alpha, it will cut both parts of the cone, and it will generate a hyperbola type figure. Or it is, yes, right, it is definitely the hyperbola. Now there is another conic section that is left, which is any guesses? Which is pair of straight lines, right? Pair of straight lines. Now what is the condition here? What is the condition here? This is alpha. Now the plane here, beta equals 0 degrees. Beta equals 0 degree, and the plane passes from the center, cutting both the cones in equal halves. So what it will make? Like this. And we will see what? just a cross, and this is pair of straight line. These are pair of straight lines. Correct? Now we have seen that all conic sections come from a cone. Later in the videos, we will discover another remarkable fact that all these curves can also be described using a single quantity called what? Eccentricity. Called what? Eccentricity, denoted by a small letter e.